So here's our 6.2 notes, properties of quadratic function. For our first example here, we are going to graph the simplest quadratic function, and it has the formula y equals x squared. So that is as simple of a quadratic function as we can possibly get. So we're going to do that by making a table of values. So table of values goes x and then y. So in this case, y is x squared. So we're going to take our x value, we're going to square it, and that'll give us what our y is. And then we are going to plot those points. So we're going to use x values of -3 all the way to 3. So -3, -2, -1, 0, 1, 2, and 3. Now, when I am substituting each of those into this equation, I have to remember that it is going to be whatever my x is and then squared for this. Okay, so my x is -3. -3 squared is -3 times -3. So negative times a negative is positive. 3 times 3 is 9. So I get positive 9. Okay, same thing. If I do -2 squared, if my x value is -2, so -2 times -2, I get positive 4. -1 times -1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And then 3 squared is 9. Okay, so plotting these points onto my graph. So here is my x-axis, here is my y-axis. So when x is -3, so 1, 2, 3 over, I'm going to be up at 9 in my y. So here's the point, -3, 9. Next point is -2, 4. So -2, 4 is right here. And then -1, 1, 0, 0, 1, 1, 2, 4, and then 3, 9. Okay, and then try to connect it with a smoother line than what I'm going to be able to do. Oh my gosh. Okay, here should be better. There. Please actually go through your points, not like me. All right, anyways. So here is our basic parabolic function. There's a couple things that we can see from this parabola. So our most basic form, our vertex is at 0, 0. Our y-intercept is also at 0. We have one x-intercept at 0. And our equation of our axis of symmetry would be x equals 0. This is what we would consider a normal width. Okay, so if we had a different value here, so let's say we had a 2, that would make this steeper. Okay, so 2x squared would have been whatever this was times 2, so this would be up at 18 at -3. -2 would have been up at 8, -1 would have been up at 2, so it would make a steeper graph, but it's not. A is just in this 1, 1. So A is 1. If we were going to have this in standard form, it would be B would be 0, and I have 0 as my y-intercept, as I can see here. So in this, if I were to look at standard form, A is 1, B is 0, and C is 0. Okay, so remember standard form is this ax squared plus bx plus c, where A tells us how it opens, so up or down, and whether it's going to be wide or skinny, and C gives us our y-intercept. One more thing I'd like you to put on this sheet is our x-intercepts. So our x-intercepts are where our graph crosses the x-axis, where our parabola crosses the x-axis. So please get that put into there. Now, for the equation of our axis of symmetry, we're going to talk about two ways to write our equation today. So the first way is to actually look at your vertex, and it's going to be that x value of our vertex, so that h, which is why in this example, our equation is x equals 0. So our x value of our vertex is just that 0. Right. So moving on to our first example. So we're given the following table. We're going to graph the points given, just like we did above, and then we're going to determine whether it's a quadratic function or not. Now, if it's a quadratic function, it should look something like this. So either pointing up or opening down. All right. So 0 and 2 is the first point we need to plot. So 0, 2 is right there. Next, we have 0.25 and 6. Now, instead of doing these each as 1, 2, 3, that's going to make everything squishy. So I'm going to say each of these ticks is going to be 0.25. So here's 0.25. This would be 0.5. This one, ooh, sorry. Then 0.75. Then 1 would be along this line. Here we would have 0, 2, and then 0.25, we're up at 6. At 0.5, we're up at 8. At 0.75, we're still at 8. And then at 1, we're down to 6. And at 1.25, we're down to 2. And let's just, ugh. Oh God, actually go through your points. There we go. So it does have a basic parabolic shape. Okay, so it is a quadratic function. It is in the shape of a parabola. Okay, now we're going to write the equation of the axis of symmetry. So I know that my equation of the axis of symmetry, or my axis of symmetry, goes right through the vertex. So right through either the maximum or minimum point of my graph. So it's going to be in between this 0.5 and this 0.75. In order to figure out what is in between 0.5 and 0.75, right smack in the middle, I can just take the average, right? So I want to find out what number is directly in the middle of them. I can take my average. So this works really well with x-intercepts, which we're going to talk about how we calculate those next time. Okay, so if we're using x-intercepts, we can take the average of our x-intercepts, so our axis of symmetry will be in the middle, or any 2 points that are going to be at the same height. Okay, so any of the 2 points that we have here that are at the same height, okay, so for example 0 and 1.25 are both at the height of 2. Okay, 0.25 and 1 are both at the height of 6. So I can take these 2 points, find the average. I can take these 2 points and find the average, or I can take these 2 points and find the average, and that'll give me whatever my equation of my axis of symmetry is. So as long as they're at the same height, I can take my x values and average them. So let's do the 0.5 and 0.75. It honestly doesn't matter. You can do any of the other ones. You'll get the same answer. But I'm going to use this 0.5 and this 0.75, and I'm going to find out what's right in the middle of them. So I take 0.5, add 0.75 to it. I get 1.25, divide that by 2, and I get 0.625 seconds. Okay, so lastly, I need to write the equation of my axis of symmetry. So it needs to be in the form of an equation, and it'll be x equals, because this is vertical lines have the formula x equals, because x will always be the same value along that line, and it's x equals 0.625, right? Example number 2, we're going to determine the coordinates of the vertex using the axis of symmetry for this line and the equation of the axis of symmetry, which is x equals 2. So how we do this is, first off, we sub in our axis of symmetry for x into our equation to find out what y equals. So basically, we have this point. We know that x equals 2. And for my table of values earlier, if I'm trying to find out what my y point is there, I just substitute that x value in. So that's all we're doing. We're going to take our equation of the axis of symmetry. It gives us this point when x is 2, and we're going to find out what y equals by substituting it into our original equation. Okay, so our original equation is 4x squared minus 16x minus 9, and we're going to be putting 2 in for that. Okay, so it'll be 4, then 2 squared minus 16 times 2 minus 9, and then you're just doing bed mass. Okay, so 2 squared is 4, 16 times 2 is 32, and 4 times 4 is 16, so 16 minus 32 minus 9, we get negative 25, which does make sense. So it's usually a good idea to take a look and make sure your answer makes sense. So if we take a look at this equation, I can see from this a value that is going to be opening up. Okay, so I'm going to be having it open up. I know that my y-intercept is going to be down here at negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so at negative 9, the equation of my axis of symmetry is 2. Oops, right here. So I know that it's going to be symmetrical along this line. Here's my y-intercept. It's opening up, so it's going to be something like this. Okay, so I'm expecting for my vertex to be 2, because that's along my axis of symmetry, and then some number that's going to be less than -9. I can see that it's going to be lower than -9 here, which it is. So -25, yes, is lower than -9. My answer does kind of make sense if I think it through. Okay. Second step is just to now write our vertex as a point. So I'm asking for the point of the vertex. I don't just want the y value of it. I was given kind of my x value. I'm just writing it as an HK or like XY point, right? So 2, -25. There. Okay, next we're going to use a graphing calculator or the Desmos app. So I would suggest downloading the Desmos app. Okay, so just take a minute, download that, and then open it up. It's going to be x squared plus x minus 2. And we are going to be looking at its direction of opening, its y-intercept, its x-intercepts, the equation of the axis of symmetry, the coordinates of the vertex, and the domain and range of the function. So before we do that, domain and range. So our domain is all the x values that the function passes through. And our range is all the y values that a function passes through. So in the case of a parabola, my x values are going to be okay. I can have x equals 0. I can have x equals -1. I can have x equals -2, -3. I can keep going and going and going and going. And I will always be able to, even if I get to -1,000,002, I can still square that. So all x values work for quadratic functions. So how we write that is we just say for our domain, it's just all of real numbers, x, and then this is just a fancy way of saying is in. So our x values are in or is in the set of real numbers. Okay, so the set of real numbers is like that, R with those 2 lines there. So that's set notation, right? So it keeps going left. I can keep putting, positive numbers in. All numbers work for this. Okay, the range depends. Okay, so for this case, my y values, I have all of these numbers up here if I just follow this down, and then it goes all the way down to 0 for this one and then starts shooting back up. So for this one, my range would be y is greater or equal to whatever that vertex is. So in this case, 0, okay, because we have a minimum point there. So when I have a minimum point, it's just going to be greater or equal to whatever that vertex point is. Okay, in this one, it goes up to a certain point. So I can't have any values that are greater than that. So y has to be less than or equal to whatever this point is. Okay, I can't go any higher than that. My y values all happen underneath that point. Okay, so when I have a maximum and a minimum, that's going to change what my range is. So when I have a minimum, y has to be greater or equal to whatever my k value is for my vertex. Okay, when I have a maximum, it has to be less than or equal to whatever that k value is for that vertex. Okay, back over here. All right, so there are some things that we can figure out without even putting this into a graphing calculator. So these are the things that we need to find: the direction it opens, y-intercept, x-intercepts, axis of symmetry equation, vertex, its domain, and range. So some things that we already can just put in. Now we know that this is going to open either up or down based on whatever that a value is. So this is a +1. Okay, so since it's positive, it's going to open up, right? Yay, opening up when we have positive a. Our y-intercept, we can tell directly from this equation when it's in standard form, because it's going to be whatever this constant is. So this gives us our y-intercept, and our y-intercept is at -2. It doesn't tell us our x-intercepts, it doesn't tell us our axis of symmetry or our vertex, but we do know our domain is going to be everything. Okay, and range, since this is opening up, I'm going to have a minimum value. Okay, so my y's are going to be greater than or equal to whatever that minimum value is. So we need to find our vertex for that. So going into your Desmos app, x squared plus x minus 2. There, that is good. squared plus x minus 2. Good. So use your finger and you can click on your x-intercepts, you can click on your y-intercept, and you can click on your vertex. All right, so when I click on my x-intercepts, I see there's one over here at -2 and then one at 1. Okay, so my x-intercepts are -2 and 1. So crosses my x-axis at x equals -2 and x equals 1. The equation of my axis of symmetry I can tell from wherever my vertex is. So my vertex is right here down at the bottom at -0.5, -2.25. So -0.5, -2.25. And I should say -0.5 there, but I just got lazy. Okay. And then the equation of my axis of symmetry is going to cut through wherever my x point is. So -0.5. So my equation, I need to have x equals, and then -0.5. Here, I'll put it proper there. And my range, so my graph passes through all y values that are higher than this point. So this -2.25 point right here. And that's it. There's our range, domain, our vertex, our axis of symmetry, our x-intercepts, our y-intercept, and the direction that it opens. Okay, and that should be good. Your assignment, you've already done this one, or you should have from last time. So all you need to do is your worksheet, not all of the questions, so just numbers 1 to 3 and 5 or 6, 7, and then 8 or 9. If you want, you can do some extra for practice, but that is all that is required of you. Okay, have a good day, guys. Bye.